Yes, sir. Yes, sir.
So, are you getting? You getting the?
Yes, sir.
Okay. So, what is the output you are getting for positive cycle? Anyone? Hmm? Plot the voltage transfer characteristics V out versus V in for the range of -10 to 10. So, what will happen if we transmit from zero cycle from 0 to 10 volts? Will it conduct?
Sir,
The
for
what?
sir, for 0 to 0.6, it does not conduct.
Yeah. Okay. 0.06 it will not conduct, right?
And
Till
for
cut off
0.6 to
till
10,
cut
it
off
will
frequency it
conduct.
will not conduct, right? So the conduction will start from 0.6. It will act as forward bias. That will act as forward bias from 0.6, right? Okay. So what's the output at forward bias in forward bias condition? Just calculate use the
Sir, R
voltage.
divided by R plus RF into VL.
Yes, V V out is equal to R by R plus resistance in diode RF, right? And you have the cutoff voltage diode V1 minus 0.6. You got it? Everyone understood
Sir,
what
I
we're getting
couldn't.
there? Yeah, everyone understood what we're getting there. So is there problem? Any problem to anyone? Uh, trying to
Sir, I
understand.
couldn't understand.
Yes.
Sir,
What
I
about
couldn't.
others?
Sir,
You understood?
no, sir.
You didn't understood. So there is a diode here D. So suppose it considered in two cycles from -10 to 0 and 0 to 10. There will be negative cycle and it is positive cycle. 0 to 10 volts it is positive cycle. So we'll try to increase voltage from 0. Just wait, just wait. Okay. So we increase the voltage from 0 to 10 volts. Okay. So from uh, diode D will has a cutoff of 0.6, right? So till 0.6 volts, it will not conduct. It will be in reverse bias condition. Okay, it will happen as act as open circuit. Understood?
Yes,
So
sir.
from 0.6, it will start conducting. It act as forward bias. Then it will be short circuited. In forward bias condition, the diode has input internal resistance of 20 ohms and cutoff voltage of 0.6. You can use the nodal analysis, find the output at R, resistor R. So it will be V out is equal to R by R plus RF into V in, V1 minus 0.6, right?
Okay, sir.
Yeah. Um, what will happen in reverse by this minus 10 to 0, the negative cycle?
There will be no output.
Yeah, the output will be in 0. Okay. Can you draw this transfer gap V out V out versus V in? Thought?
Yes, sir.
Yeah. So it will start from 0.6, right? Linearly it will increase till 10 volts. Okay. Okay, fine. So everyone understood that?
Sir, the maximum output voltage is at 9.21.
Yes, yes. 9.21. So you check the value maximum voltage. Put 10 volts there. V1 point 10 minus 0.6 into 1000 by 1020. You check the value how much you are getting. That's the maximum voltage we are getting. So everyone got the answer right? Try to solve the second part, B part. Now consider the sinusoidal with 10 volts maximum voltage amplitude. Then find the average values, peak values, and PIV, peak inverse voltage. What is peak inverse voltage? Anyone know? Why it is important?
Sir, is it VL minus V gamma?
V
V in minus V gamma.
which one? Part A. You're saying that?
Peak inverse voltage.
I'm asking what is peak inverse voltage? Why it is important?
So the maximum voltage in case of a reverse bias condition.
Okay. So while buying a diode, we should see that the voltage should be greater than the PIV, right? Else it will break down. If it is less than that, the diode will go to break damage. Okay. Okay. Try to solve the second part, B part. So everyone got part A, right? So what is the formula for your average value? Anyone?
Sir, integral v dt by t,
What's that?
0 to 2.
Sorry, can you repeat that?
Sir, basically integration from 0 to 2 pi v dt whole divided by time period, that is 2 pi.
You are saying for sinusoidal signals. What's it for general
Yes,
case?
sir. S- Sir, for general case, like it is same, just the limit will be changed. And in division, it is integral that limit from a to b, that like what is endpoints. So let's say a function of x, then its average will be integral f dx, limit let's say from a to b whole divided by dx a to b.
Okay. So basically, it will be integration of from zero to time period. So
Yes,
one
sir.
time period and divided by time period, right? One time period. Okay. Uh, so in this problem, you will take the sinusoidal signal, right? So calculate the output voltage. So how much output you are getting there? So what are the cutoff values you have for the circuit for this waveform? I calculated cutoff values omega t1.
Sine inverse 0.06 and pi minus sine inverse 0.06.
Okay. What's the value? 0.06 value of.
Sorry, sir.
What's the value of 0.06? How much? How many degrees you are getting? What's the angle?
Sir, I have to check. I am doing, sir.
Yeah, calculate that.
Sir, 3.43 degrees.
Okay. 2 point. Okay. What's the other angle you're getting? So it will connect in only in positive cycle, right? You will get two cutoff frequencies, two cutoff values, right? At 3 point, you are getting some 3.6, 3.2. So
Sir,
it
what
will be
is the value of omega?
omega.
Yes.
Yeah, calculate the value of omega t.
No, sir, for like average, we need omega.
First one do this. First of all, what's the other cutoff value? Omega t. So it will be omega t value. You are getting this 3 point, right?
Sir, I got omega t is equal to 3.43.
2 point, 3 point or 2 point. So you will get this omega t1 sine inverse of 0.06. So it will be. Let me check. So actually, I am getting 3.44, right? 3.4.
Yes, sir.
Yeah. So convert it to radians. What's in value in
I'm
radians?
converting it to radians 0.059.
0.059. How you converted? Pi by 180.
Yes, sir, pi by 180.
So you're getting some. 3.44 divided by 180. So you'll get the 0.02 around radians, pi radians. 0.02 pi radians. So what's the other cutoff frequency they are getting? So other cutoff frequency at around 180 degrees, and it will be at 0.6. So subtract 180 minus subtract 0.3.4, right? Can you see my screen?
Yes, sir.
Yeah. So here you can see this in figure around 1.27. It is a similar diagram, right? Here we choose the ideal diode. So it is conducting from 0 to pi. For our case, we are using for 0.6, cut off of 0.6. So it will start conducting from 0.6 to now it will go from exactly some um, between 0.5 0 to pi. Okay, so there will be two cutoffs here at 0.6 here, and the maximum minus 3.4 here. There will be two cutoff frequencies. So that two cutoff frequency will be here. You are getting 3.4, and it will be pi minus you are getting 0.2 radians, right? 0.02 pi radians. So both are the maximum values, cutoff values. Okay, you're getting right.
It will be frequency.
We are taking with omega t. We are taking
Okay, sir.
omega t value pi radians. Okay, with respect, not with respect to frequency. It will be taking with respect to omega t, basically time, right? Omega will be 2 pi by t. So what's the average value you're getting there? What about others? No one responding. Only Aman goes. I think responding.
Hello, sir. Can you explain it once again?
Can you?
Can you explain it once again?
So at which point you are stuck?
Uh, Sir, like we'll take average from the point where the voltage is reaching 0.6, right?
Yes.
And then to the point, like from there to which point?
Again, can you see my screen, right? So we are continuously increasing the voltage from 0 to it will go to maximum value. Then it will go again, will decrease the value. No? So at 0.6 at both the ends, that diode should stop conducting, right?
Okay, yes, sir.
Yes. So we'll get the two cutoff frequencies as here, two cutoff points. At around one cutoff is 3.4 we are getting. So other will be 180 minus 3.4.
Okay, yes, yes, sir. Got
Yeah,
it, sir.
yeah.
Sir, we are getting 3.4 degrees.
Yeah,
So
degree. Convert it to radians.
converting it into radians, 3.4 into pi by 180. So
Yes.
we will get, sir, 0.06, not 0.02.
0.06. 3.4 you're getting right?
Yes, sir, 3.44
Yeah, 3.44 by 180.
into pi.
Yeah, I'm taking pi radians. 0.02 pi radians. You're multiplying pi, I think. So if you multiply, also no problem. So you'll get the 0.02 pi radians. Okay. So now calculate the output voltage. Value. So it will be V out is equal to 1 by 2 pi. Time period of this is 2 pi. So integration of 0 to 2 pi. The output voltage will be 10 times of sine omega t.
Sir, we will integrate from 0.02 pi to 0.98 pi, right?
Yes, yes. So
Like for
other
the
will be 0.98.
yes, sir.
Okay. 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 We integrate it there. Uh, Fine. So what's the output you are getting that? 10 times of sine omega t minus 0.6.
Sir, is the average value is 1.7868?
What's the average?
1.7868.
1.786. So everyone getting the same answer? I think you will get the integration from uh, 10 sine x. So sine will be converted to cos, integrate minus cos.
Sir, actually, output is R divided by R plus RF into that 10 sine of omega t.
Yes, yes, yes,
Then we have to integrate.
yes. So you'll get the 10 times of minus 10 cos x minus 0.6 cos x, 0.6x, right? Yeah, I'm getting that.
Hello, sir.
Yes.
Sir, can you write somewhere if it is possible?
Okay, let me just go there. Very good. Like I'm trying to Actually, I don't have the writing pad. That's the problem. So I'll try on paint to write on paint. So what's the issue you are facing there? You're trying to understand that.
No, so I was thinking if you will write, then it will be better.
My
But
paint
it's
is
okay.
my paint is not working. The writing pad is not there. So let's see. Um, so once check this figure 1.27 there. Understood that, but the average value is okay. I'll try to write that. Yeah. 1/2 pi. Sine. Can you see my screen? Right?
Yes, sir.
Yeah. So it will be range from 0.2 pi 0.02, right? 0.02 pi radians to what's the other value? 9.8, right? 9.8 pi radians.
Sir, 0.98.
0.98, right? Okay, sir. 0.98 pi radians. So you can integrate this value. Consider this omega values this as x, right? I consider omega t value as x. Integrate this value, then you will get the answer, right? This is the omega t 1 point, and this is the other omega t 2 point. So there will be two cutoff frequencies. Okay. Fine. So how much answer you are getting there?
Sir, I got 3.13.
3.13. Okay, everyone getting the same answer? Okay. So it will be around 3 volts. Okay, what the peak value you are getting? Anyone tried that peak value?
Sir, is my answer correct?
It will be around 3 volts.
Yes, sir, I am getting 3.13.
3.13. Yeah. Okay. Fine. Correct only. So okay. So what's the peak value you're getting? Output peak voltage. Someone said that's 9.2, right?
Sir, it's 9.21.
Okay, right. Its peak value is to 9.21. Fine. Okay, so what's the peak inverse voltage? How to find the peak inverse voltage? Do you know? So whatever others, no one responding. Only the two members are responding continuously. Whatever others, are you getting or not? Is there in doubt? We first want to solve the other sections also. Okay. Just apply the KVL there around the diode. So it will be V1 minus V. So the peak inverse voltage will be 10 volts. Everyone got it?
Yes, sir. Actually, sir, I had to just confirm that there is no other voltage, so we will just take a 10 of 10 sine omega t. I
Right, right.
mean, that 10 of, yes, sir.
Yeah. So you're getting directly 10 volts as peak inverse voltage, right? Okay. So everyone got the answers, right? Everyone understood? Okay, fine. Okay. We'll solve the next question, right? We'll continue for next question.
Sir, your screen is not visible.
Okay. So which question you want to solve me? Solve. If you have, do you have book, Neiman book? We'll solve one more question in this section and we'll go for other sections. Uh, So now you know how to solve the average values and uh, what's the RMS value? Do you know how to calculate the RMS values? Anyone?
Sir, root means square.
Yeah. So already you got the average value, output voltage. Then you take the formula of integration square root of oldest square, integrate of oldest square. Okay. So you can find the
So do we
RMS
have to
value.
find the RMS value of the
No, no,
previous?
no, not that question. Just I'm asking, simply asking. Okay. Try to solve it to 2.3. 2.3. A half wave rectifier such that a half wave rectifier such that shown as in figure 2.2a. 2.2a. think figure is missing somewhere, right? Figure is not there. Solid 2.6. 2.5. Okay, right. Uh, once read the question, 2.6. The full wave rectifier circuit shown in figure 2.5. A. The text is to deliver 0.2 amps, 12 volts peak values to a load. The ripple voltage is to be limited to 0.25 volts. The input signal is 120 volts. So, so basically, what basically transformer does? Anyone? So we're giving input as 120 volts. We're going to take the output at after transfer to 12 volts. So we're going to decrease 10 times, right?
Sir, N1 by N2 is 10 by 1.
10 by 1.
N1 is primary coil, right? So it have more number of turns than N2.
So it is given RMS value 120 volts as RMS value. Convert it to
Okay.
peak to peak.
Sir, is it approx 14.1 for like 14 turns is to 1?
What's the peak to peak value?
Sir, 169.705.
169. It will get
Yes,
120 root 2.
yes, sir.
120 root 2. Okay. So you have to get the output at Vs as how much you already 12 plus 0.7. So divide 12.7. Okay, 169. 169 is okay. 169.7. Right? Okay. 169.7 by so you have to convert that 120 volts to 12 volts. 12 plus. So you have cutoff of diode is 0.7. Right? So you'll get the 12.7 at Vs. Understood?
Sir, Vs is V0 minus V gamma.
We not?
Minus V gamma, right?
Sorry. VB. Vs minus 0.7 minus 12 is equal to 0. Apply KVL there. So you will get the uh, 12 plus 0.7, right?
So can you repeat?
So Vs minus 0.7 minus 12 is equal to 0. Here they are using the center tap transformer. So you can apply.
Sir, but for positive half cycle and negative half cycle, they both are different, right? So,
No problem.
sir, for positive half cycle, V output is Vs minus V gamma, and for negative half cycle, it is minus Vs minus V gamma.
No.
Sir, by applying KVA.
No, positive half cycle it will be forward bias and totally minus to plus. You will get for negative half cycle it will be in reverse. Just the sign will be reverse. The value should be same. So for suppose if it in forward bias or positive cycle, uh, the D1 will be connected. Suppose in reverse bias it will be in D2. D2 will be connected. So only one diode will be active, right? Understood? So so if you apply KV also, the if D1 is on, the D2 will be off, or if D2 is on, the D1 will be off. So the peak voltage will be 12 plus 0.7. Got it? Understood?
Sir, I have still doubt. Like for let's consider for positive half cycle. Uh, let's say at that point, where the N2 is written. So let's say it is grounded. So it is 0 volt, right?
Yes.
And for positive half cycle, D2 does not conduct and D1 conducts. So the voltage is Vs minus V gamma.
Vs minus V gamma. Okay.
Yes, sir. That is for positive half cycle. And for negative half cycle, that point where the N2 is written is grounded, and for like Vs is inverse, right? So minus Vs plus V gamma means minus V gamma because D2 conducts. So minus Vs minus V gamma. So voltage is minus Vs minus V gamma output voltage.
Okay. Tell me, in reverse bias, negative cycle will it conduct diode?
No, sir.
Then why are you taking the so it will conduct in powered by positive cycle only. Okay. Understood?
Okay, okay. Sir, is it half level?
Sir, I couldn't get.
Hello.
Sir, I couldn't get it.
Can you see my cursor?
Yes, sir.
So apply KVL from this point. So I'm considering the only this upper part, right? If you apply the whole circuit also, then you will get, suppose you're taking the whole circuit, Vs minus Vs here, continuous, it will be open circuited. So there is no KVL. KVL cannot be applied here, right? Just apply KVL to this circuit. Vs D1 voltage at D1, and go to we're getting voltage of 0. VB voltage. What is VB voltage? 12 volts, right?
Yes, sir.
Yeah. So 0.7 Vs minus 0.7 minus 12 is equal to 0, right?
Yes, sir.
So peak voltage is equal to Vs minus 0.7 minus voltage load is 12 is equal to 0. Okay, this is the peak voltage. This is the peak voltage, right? Is equal to 12.7. So before that, you were getting input voltage as 16 point, right? 16.9, 120 root 2. So N1 by N2 ratio, N1 by N2 ratio is input peak by output peak, right? 120 root 2 by 12.7, right? Understood? This is a ratio.
Yes, sir. Sir, actually, I was asking how is it Vs minus V gamma and minus Vs minus V gamma? It should be minus Vs minus V gamma. That's what I
VS
was asking. Sir, like in the positive half cycle, output is Vs minus V gamma, and in the negative, it should be minus Vs minus V gamma. Even in the book, it's written, sir,
minus Vs
minus V gamma.
minus V gamma. Apply KVL. I didn't
Yes, sir.
understand where it is given. Where it is given?
Sir,
Minus
in
Vs.
the minus Vs minus V gamma. Sir, for the negative half cycle.
Okay, just wait. At which point you are getting there? Here, this one. So if in a negative half cycle also you're getting the
Sir, for when D1 will be conducting, it will be Vs minus V gamma, and when D2 will be conducting, it's minus Vs minus V gamma.
for peak voltage, we have to calculate the peak voltage, right? We have to calculate the peak
Yes, sir.
voltage for peak voltage. Take the positive cycle. Okay. For calculating peak values, peak voltage, take the positive cycle values, not negative cycle. Fine.
Okay, sir.
Sir, what is the reason for that?
Actually, we're taking for this now. Suppose the diode will be in past here. Um, the diode will be in past cycle to give maximum values. So maximum value, either it will be in reverse bias also. If in reverse bias, suppose if you consider a diode is conducting only reverse bias, then taking reverse bias, it will give the maximum value in reverse bias. Okay. Um, but here we are not using Zener diode. Here we are using the PN diode. Uh, so for peak values, we'll take the usually we will take the positive values. Okay, have you understood what is the peak voltage? What is the why we are taking peak? What is meant by peak voltage,
Sir, maximum output voltage.
right? Then it's fine. We are taking the maximum output. Okay. So what the problem you are getting? Can tell me once. So you are taking the reverse bias for peak values. Consider only positive cycles, not the negative cycles. Uh, okay.
Sir, but sir said that we have to consider both cycle and then choose for peak voltage.
Both sides.
Yes, sir. Because we have to see that in which cycle it is maximum.
So what's the maximum you're
Because
getting?
this one is full wave rectifier.
So suppose
Sir, that value is correct. That is 12.7. I understand, but that is coming in negative half cycle, right? So I am confused
Yes,
between
sir.
that.
Yes, sir. It's coming in negative half cycle.
Because in positive half cycle it is 12 minus 0.7, so it is 11.3, right?
so you're getting negative half cycle.
Yes, sir.
Just wait. So what for negative half cycle you're getting same answer. No? Okay, let me do it for that. Okay. I'll come to that. Try for the second part, B part. Find the required value of the capacitor. Have you find the capacitor value? Part B. Anyone?
Sir, we have to use that formula, right? VR equals to Vm by 2 pi 2 FRC.
Yes, that one.
So what is the value of R here?
R 60 ohms is given.
No, sir.
We given the, just wait.
Voltage and current is given, sir.
Yes,
Oh.
sir. Yes, sir. Great.
So you're getting maximum value at positive cycle itself, no? 12.7. Hello? What's the value you got for capacitor?
Sir, 7 millifarad.
7 millifarad. So for negative cycle, you're getting maximum value at positive cycle, no?
Yes, sir. Got it. Like I am like doing VSS 12. Like I am taking VSS 12.
Now you understood?
Yes, sir. Yes, sir. Got it. Thank you, sir.
Okay. Okay. You got the answer right. Have you found the peak inverse voltage? That PIV rating.
Sir, what is the value of capacitance?
Someone said the 7 millifarad, right? That one is right. Approximately, you will get that. That one. Okay. What's the peak inverse voltage? So peak inverse voltage will be 2 times of maximum voltage minus 0 gamma V gamma. You got it? Peak inverse voltage?
Yes, sir.
Yeah. How much value you got?
24.7.
Right. 2 times of maximum voltage. Yes. Minus 0.7. Right. So basically, these are things in section 1, rectifiers. Uh, you try this. Try this. So we'll go for other section. Next section. Xena diodes. Okay. Okay. Try to solve 2.19. Okay. Consider circuit shown in figure 2.19. Xena diode voltage is VZ. It's given voltage of xena diode is to 3.9 volts. And resistance of 0. Internal resistance is 0. Find the current flowing in xena IL and load current. Okay. How to find the load currents there at 4 kilo ohms? Anyone?
So, like the voltage 20 is far greater than 3.9. So, the load current will be 3.9 divided by 4 kilo ohm.
Yes. Okay. What's the value do you think? What's the answer? 3.9 by 4. Let me see. So you will get around 0.9 milliamps.
So, 0. Yes, sir. 0. 975 milliamps, right?
Yeah, yes. 0.975.
0.97.
Yeah, milliamps. Okay, what's the current flowing in 12 ohms, 12 kilo ohms? So now you got the given VZ voltage as 3.9, right? So you can apply the nodal analysis. So 20 minus 3.9 by 12K.
Sir, 1.34 milliamps.
Okay. Okay. And, now what's the current flowing through the diode? Xenon diode. So you have the max
0.36 milliamps.
yeah total current flowing through 12K is 3 point what 1.3. 1.3. So from 1.3, 0.9 is flowing through load. So the remaining current is flowing from diode. Okay. So 0.3 is a milliamps is a current flowing through diode. Okay. So what's the power?
VZIZ.
Yeah, VZ is equal to IZ VZ. So you have the VZ and IZ values. Everyone got the answer? Hello?
Yes, sir.
Yeah. Uh, try for second circuit also. 2.20. Solve the next question. 2.20. Similarly, you can find it for 10 kilo ohms also. The previous question. Okay, you can do this. So there is less time to finish this other sections also. Finish completely the next question. Go for next question. Consider the Zener diode circuit shown in figure 2.20. Assume Zener voltage is 12 volts. Started Zener diode current and power dissipated in the Zener diode for R useful. What's the current flowing through Zener in 22.20?
0.23 ampere.
Yes. Okay. What's the power you're getting? How much power is flowing? You're getting there?
Sir, 2.8 watt.
Okay. 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 What is the value of RL such that?
Sir, what is the value of RL? Sir, is it implement? Okay, sir.
Okay. Have you solved the problem? Part B. What is the value of RL? You got the answer for RL? Load resistance. Have you calculated? You got it. What is the load current you are getting? Hmm? Anyone? Anyone
Sir, I
found the
am
load?
getting RL as 56.57 ohm.
56.57. What's the load current you are getting?
It is 28 by 120 by 11.
20?
0.0023 ampere.
Okay. So everyone getting the answer? Let me ask someone other. Arvind Tripathi? Arvind Tripathi? Is he here? Anupam Sharma? Those who are not responding, I will put them absent.
Sir, could you
Alexia?
please show the question again, sir?
Who is this?
No, Aditya, sir. Like I didn't do the B part. Like
Okay, have you tried?
no, I got the A part answer, but B part I haven't tried it.
Okay. Aniket?
Yes, sir, trying.
Yeah. Arvind Tripathi? Is he here? Ashish Kumar? Okay, you're getting what's the RL value you're getting? So how much power dissipating for from zero diode? Anyone solve?
Sir, 0.254 watt.
0 point.
254.
So how did you find the power dissipated?
Sir, the current through Zener into the voltage option.
Okay, what's the value? 0 point.
254 watt.
What? Watt or volt?
Yes, sir. Watt.
Okay. Okay, fine. So everyone got the answer right? Alok Kumar? Okay. Okay. Try problem. Just wait. 2.24. Just wait. Voltage regulator. Solve
Sir,
problem 2. Problem
what was
2.2.
the value of RL in previous question?
Value of RL.
Sir.
Someone got 56, right? 56, I think so.
56.57 ohm.
Yeah. Okay. So solve 2.23. A Zener diode is connected in a voltage regulator circuit. So how to find the maximum uh, current there in Zener diode? Anyone? Determine the value of RS such that Zener diode remains in breakdown if the load current varies from. So it is here load is varying. Load current is varying from 50 to 500 milliamps. How to find the varying current? So there's a varying.
Sir, if it is in breakdown, that the voltage is like a voltage across load is equals to Vz, right? So like we put the value of IL and then find the maximum value of RL.
Okay. Find the maximum current there, Zener. Can you do it? Quickly solve this question. You got it?
Sir, resistance is 20 ohm.
Resistance is?
Determine the R. So like R max is 20 ohm.
No. What's the maximum current you are getting, Zener? What's the maximum current you are getting there?
Sir, can you please show the figure? I like the volt. The diode is in series with that voltage regulator.
Yes. Right?
Okay, sir, got it. So what's the maximum current you are getting, Zener? How to solve it? Maximum current?
Sir, when there will be no current through zener, then that will be. Sir, maximum current for
Maximum current. Yeah. When there is no current flow from load, there will be maximum current flow from zero. So minimum current or flowing from load, we'll get the maximum current flow from there, right? So for flowing minimum current in load, what should be the RL value you use? So you given the load varies from, you're given two values, two current values from load, 50 amps and 500 milliamps. Which current you are using there? Minimum. So you'll get the IZ is equal to I1 minus IL minimum. So you'll get the answer. I think it is 1.2 amps.
Sir, can you please show the question?
Push. Let me sum out. So can you see?
Yes, sir.
Yes. So here is a formula for finding maximum current in zener. Can you see this? Equation 2.30. Can you see
yes,
this?
sir.
Yeah. Okay. So so resistance at input is equal to. So you can see this, equating both the equations here to find the maximum and minimum values. So you will get the finally you'll get the current, maximum current through load. So this is the formula you can use directly with that 2.30. So minus you can find the maximum voltage, maximum current. Okay. So what's the maximum current you're getting there in zener? 2.7. Point. So you'll get the I think I did 1.2 amps. maximum current flowing through zener. Okay, I'm not sure. Just try once again and confirm. Is the answer correct? Are you trying? Anyone? Anupam Sharma, Chitra Momsri, Srivastav, Mridula.
Trying.
Yeah. What's the value you're getting there, zener? What's the maximum zener current you're getting? Priyajit, Priyanjit, Neeraja, Santosh. Those who are not responding, I put them absent.
Yes, sir.
Yeah. What? Who is this?
Santosh.
Okay. What's the maximum current you're getting then, zener?
Solving, sir.
What?
Solving, sir.
Yeah. How much you got for previous answer? Have you solved the previous question? Okay, fine. You solved this question. This question 2.23. No one responding. I will leave to this question to you. We'll go for next question. One more question.
Sir,
Yes.
sir, we have another class. So,
At what time?
sir, like 10.
10 o'clock. Okay, in 5 minutes
Yes,
we'll finish that question. We'll go for next section. You try for this problems, remaining problems. You can ask me anytime if you have any doubts. Trying to solve. So I covered. These are the type of questions they will have all the questions. So if you understand these questions, you can solve other questions also. So if you have any doubts, you can message or call me. You can ask any TA also, other TA also. Okay. Okay. When you have the next TA tutorial?
sir, I think on Monday.
Okay. We will continue on Monday then.
Okay, sir.
Okay.
Thank
Yeah.
you, sir.
Till then, complete this zero dash circuits to section 2.2 and 2.1. Okay. You can, if you have doubts, you can ask in next section also, or next class. Okay. Okay, then you can leave the meeting.
Thank you, sir.